Today, we will see the first law of thermodynamics and its special forms for different types of processes. Now, at the school level, you might have studied the first law of thermodynamics. This first law of thermodynamics is nothing but an extended form of the law of conservation of energy. So, we will see what are the different statements of the first law of thermodynamics in this lecture, and we will also see how this law can be deduced for different processes, which we have seen earlier. Coming to the statements, the very first statement of the first law of thermodynamics is that total energy of a system and its surrounding remains the same. Total amount of energy of a system and its surrounding remains the same. That is, the sum of energy of system and the energy of surrounding that remains the same or constant. So this is one of the form of the first law of thermodynamics. Now the second statement which can be stated for the first law of thermodynamics is that total energy of an isolated system remains constant, though it may change from one form to the other. It means there is possibility of change of one form of energy into another, but that is, one form of energy can be converted into another, or another form of energy can be converted into the first form of energy. But at the same time, the total energy of that particular isolated system remains constant. So this is one of the statements of the first law of thermodynamics. Now, what is isolated system? This we have seen previously. Isolated system is a system which can neither exchange energy nor matter with its surrounding. That is called an isolated system. So, according to the second statement of the first law of thermodynamics, we can see that total energy of an isolated system remains constant, though it may change from one form to the another. Then we can also say that whenever a particular form of energy disappears, an equivalent form of another type of energy is produced. That is, it is related with the conversion of one form of energy into another form again. So, according to this statement, whenever a particular form of energy disappears, an equivalent form of another type of energy is produced. Now, the next statement of the first law of thermodynamics is that it is impossible to construct a perpetual motion machine. It is impossible to construct a perpetual motion machine which can do work without spending energy. Means, in order to do some work, we need dissipation of some kind of energy. We need use of some kind of energy. So here the first law of thermodynamics can also be stated as it is impossible to construct a self-perpetual machine which can do work without spending energy. What is this perpetual motion machine? Perpetual motion machine is nothing but a kind of machine which can do work without spending energy. A perpetual motion machine is a machine which can do work without consuming energy. But in practical, there is no 100% perpetual motion machine. No machine can do work without consuming some energy. So this seems to be a hypothetical here. That is, it is impossible to construct a perpetual motion machine which can do work without spending energy. Now the next form of statement is that for a closed system, the net energy change is equal to heat transferred to the system minus work done by the system. Now this sentence or the statement will be more clear in the next slide when we consider the mathematical form of the first law of thermodynamics. So for a closed system, what is the net energy change? That net energy change is equal to the heat transfer to the system minus work done by the system. So up till now, we will see 5 different statements of the first law of thermodynamics, which I repeat here. That is, the first law of thermodynamics is nothing but the extended form of the law of conservation of energy, and it can be stated in different forms. So what are the different forms of the first law of thermodynamics? The very first statement is that the total energy of system and its surrounding remains the same. It means the total amount of energy of system and its surrounding remains constant, and the system and its surrounding constitute the universe, so that we can say that total amount of energy of system and its surrounding, that is total amount of energy of universe, remains the same or remains constant. So according to the first law of thermodynamics, total energy of the universe remains constant. Total energy of the universe remains constant. Now the second alternative statement for the first law of thermodynamics is the total energy of an isolated system remains constant. Total energy of isolated system remains constant, though it may change from one form to another form. Now this isolated system, what is this isolated system? Isolated system is nothing but a system which can neither exchange energy nor matter with its surrounding. Such type of system is called isolated system. And in case of isolated system, here the total amount of energy of that particular isolated system that remains constant, though there may be a change from one form of energy into another form. That is, there is exchange of energy from one form of energy into another form of energy. That is interconversion. Rather than exchange, we can say there is interconversion of energy from one form to the another form, but total energy of that particular isolated system remains constant or remains the same. The third statement of this first law of thermodynamics is that whenever a particular form of energy disappears, an equivalent form of another type of energy is produced. So this first law of thermodynamics is nothing but simply it is related with the conversion of one form of energy into another form. That is, when one form of energy disappears, another equivalent form of energy is produced, or we can say it reappears in another form. So whenever there is conversion of energy, one form of energy disappears and another form of energy is produced. Now let us consider here an example of a fan. Now when this fan is getting started, when I switch on a fan, what happens at that time? This electrical energy is converted into mechanical energy, where the blades of fan start, and at that time some sound is also produced. That is sound of that particular fan. So here there is conversion of electrical energy into mechanical and sound. So whenever one form of energy disappears, another equivalent form of energy is produced. So that is again one of the statements of the first law of thermodynamics. I hope this concept is clear. That is, whenever one form of energy disappears and another equivalent form of energy is produced. That is, when we start a fan, at that time electrical energy is converted into mechanical energy and sound. Or when we switch on a lamp, at that time there is conversion of electrical energy into light. That is, when one form of energy disappears, another equivalent form of energy is reappears or it is produced, one can say. Then, according to this statement, it is impossible to construct a perpetual motion machine. It is impossible to construct a perpetual motion machine which can do work without spending energy. As this self-perpetual motion machine is what? It is a kind of machine which can do work without consuming energy. But actually, in practical, what happens? There is no perfect perpetual machine. There is no 100% perpetual motion machine which will do work without consuming energy. That is, it says that in order to have some work, we need conversion of one form of energy into another form of energy. Simply talking, in order to have some work, we need to convert one form of energy into another form. So that is again the first law of thermodynamics. So according to this statement, it is impossible to construct a perpetual motion machine which can do work without consuming energy or without spending some amount of energy. Then the next statement says that for a closed system, what is this closed system? This closed system is nothing but a system which can exchange only energy but not matter with its surrounding. What is closed system? Closed system is a system which can exchange only energy but not its matter with its surrounding. That is called a closed system. And now for this closed system, what is the net energy change? That net energy change is equal to heat transferred to the system minus work done by the system. Now this statement of this thermodynamics will be more clear in the next slide. So let us move further. So what is the mathematical formulation of this first law of thermodynamics? The first law of thermodynamics can be mathematically represented as Q is equal to delta E plus W. What is this term Q? Where this Q is nothing but amount of heat supplied to a system. Q is the amount of heat supplied to a system. Delta E is the change in internal energy of that system. And W is the work done by the system. Means when we supply a particular amount of heat Q to some system, at that time that heat is utilized for two purposes. First purpose is to increase internal energy of that particular system, and this internal energy is nothing but sum of all kinds of energies associated with that system, and it may include vibrational energy, rotational energy, nuclear energy, kinetic energy, and all sorts of energies associated with that particular system. So here this first law of thermodynamics can be mathematically expressed as Q is equal to delta E plus W, where this Q is the amount of heat supplied to a system, delta E is the change in internal energy, and W is the work done by system. So when we supply a particular amount of heat to a system, it is used for two purposes. First, that system will try to increase its internal energy. First, that system will try to change or increase its internal energy. And once the internal energy has been increased, it will try to do some work on its surrounding. So, the first law of thermodynamics is mathematically expressed as Q is equal to delta E plus W. That is amount of heat supplied. Amount of heat supplied to a system is equal to change in internal energy plus work done by the system. Now, coming to the previous slide, that for a closed system, the net energy change is equal to heat supplied minus work done. So it gives net energy change. What is this net energy change? Delta E. That will be, if you bring this term W to this side, that is delta E is equal to Q minus W. Delta E is equal to Q minus W. So the net energy change is equal to amount of heat supplied minus work done by that system. or simply remember the statement that is Q is equal to delta E plus W. Q is equal to delta E plus W, that is amount of heat supplied is equal to delta E plus W, that is heat supplied to a system is used for change in internal energy and to do some kind of work. Now when we say that work is done, suppose some object is lying in a particular state on a table. Suppose I place a pen on a table. Now in order to move that pen from one place to another place, I have to apply some energy, because if I do not do so, that is if I do not apply some energy, then that pen will lie on the table itself. It will not move on its own accord. So in order to move that pen or that particular object, I need to push it, or I need to apply some force on that object. And if that is if I apply some force, say F, and if that object gets displaced through a distance L, then we say that is force into displacement. The product of force into displacement is nothing but work done. So this concept can be clear. The concept of work done, we have to again derive expressions for work done in isothermal reversible expansion of gas, then again work done in irreversible expansion of gas also. So at that time we will clear the concept of work done in more detail. So at this point, remember that the first law of thermodynamics can be mathematically expressed as Q is equal to delta E plus W. Q is equal to delta E plus W, that is amount of heat supplied here. Amount of heat supplied is used to change internal energy and to do work. Now, up till now we have seen what is the first law of thermodynamics. That is, it is related with the conversion of one form of energy into another form. It can be stated in different ways. That is, total amount of energy of system and its surrounding remains the same. For a closed system, the total net energy change is equal to amount of heat supplied minus work done by the system. And again, it is impossible to construct a self-perpetual machine which can do work without spending energy, and so on. And lastly, we have seen the mathematical formulation of the first law of thermodynamics, that is Q is equal to delta E plus W. Q is equal to delta E plus W. That is the mathematical form of the first law of thermodynamics. So now, how this first law of thermodynamics can be deduced for different processes, that we will see. So let us consider what the first law of thermodynamics takes a new form when we apply it for a cyclic process. Now, a cyclic process is nothing but a process in which a system undergoes a series of state changes such that its initial and final states are same. Cyclic process, we say that a system undergoes a cyclic process when a system undergoes a series of state changes and its initial and final states are the same. If its initial and final states are the same, then what happens? Its internal energy is also same. And what is internal energy? Internal energy is nothing but the sum of all kinds of energies associated with a particular system. And if a system is undergoing cyclic process, then if a system is undergoing a cyclic process, at that time this delta E is equal to 0. And see what this first law of thermodynamics will become now. Therefore, if delta E is term in this first law of thermodynamics, if this delta E term is 0 for the cyclic process, this delta E is 0, then Q will become W. And hence, for the cyclic process, Q is equal to W. It means maximum work is done in a cyclic process. Maximum work is done in a cyclic process. Here, this A and cyclic, these two are different words. That is, maximum work is done in a cyclic. Please read it as in a cyclic process. So, maximum work is done in a cyclic process. Why maximum work is done? Because here the delta E term is 0. And if this delta E term is 0, it means Q is equal to W. That is the total amount of heat which is supplied to a system that is completely used to do work. And there is no change in internal energy. So for this, because why there is no change in internal energy? Because it is a cyclic process, and in cyclic process we know that its initial and final states are same. And if its initial and final states are same, this change in internal energy is 0. So here Q becomes equal to W. That is, we say that maximum work is done in case of cyclic process. Maximum work is done in case of cyclic process. That is, the amount of heat supplied is completely consumed to do work, and there is no change in internal energy. So for this cyclic process, we use the concept of maximum work. And based on this concept, in the second part of thermodynamics, we are going to see the cyclic process, that is Carnot heat engine, the concept, a new concept that we will see in the due course. So for the cyclic process, for a cyclic process, what happens? Delta E is equal to 0, because here in cyclic process initial and final states are the same. It means internal energy of that system is remaining constant, means delta E is equal to 0. And if delta E is equal to 0, then according to the first law of thermodynamics, what will become here? This, if this term is 0, then Q will become equal to W. So if Q is equal to W, maximum work is done in this cyclic process, and we say that amount of heat supplied is completely consumed to do work. Now for the next definition, that is isochoric process. Now what is this isochoric process? Isochoric process. Iso means same, core means volume. Iso means same and core means volume. So isochoric process is a process in which volume of the system remains constant. Volume of the system remains constant. If volume of the system remains constant, it means delta V is 0. The change in volume is 0. And we know that we have one formula for work done, that is W is equal to P delta V. W is equal to P delta V. So if the process is isochoric, if this process is isochoric, then what will happen? Delta V is equal to 0, and therefore W is equal to P delta V becomes 0. And therefore, from the first law of thermodynamics, the mathematical statement of the first law of thermodynamics, that is Q is equal to delta E plus W, becomes Q is equal to delta E. That is, Q at constant V is equal to delta E. Q at constant V, that is equal to delta E. It means the total heat content of a process or a system at constant volume is equal to the change in internal energy. So that is a new definition of internal energy. One can say that change in internal energy is equal to the total heat content of that system at constant volume. Change in internal energy, here we get a new definition of change in internal energy. We know the definition of internal energy, that is the sum of all kinds of energies associated with a system. Here we get a new definition of change in internal energy, that is nothing but total heat content of a system at constant volume. So for this isochoric process, we know that this isochoric process is a process in which volume of the system remains constant, that is delta V is equal to 0, and therefore W is equal to P delta V. And since W is equal to P delta V, then from the first law of thermodynamics, we get Q is equal to delta E, because here this work done term is 0. If that work done is due to pressure volume type of work done, then Q at constant V, that becomes delta E, that is the total heat content of the system at constant volume is the change in internal energy. So here we get a new definition of change in internal energy based on the first law of thermodynamics for isochoric process. That for adiabatic process. Now adiabatic process is a process where no heat enters into or leaves out of the system. Adiabatic process is a process in which no heat enters into or leaves out of the system. And here therefore Q is equal to 0. That is, total heat content of the system is remaining constant. no heat can enter into or leave out of the system, and therefore for adiabatic process, this term Q is equal to 0. And therefore, according to the first law of thermodynamics, that is Q is equal to delta E plus W, that is I write here delta E plus W, that is going to be 0. That is delta E is equal to minus W. And what does it mean? Or simply, that is delta E is equal to minus W, or minus W is equal to delta E. If we bring this minus sign here on this side, this W will be positive and this delta E will be negative. So here, for adiabatic process, what is the conclusion of this statement? What is the conclusion of this mathematical statement? For adiabatic process, minus sign it means decrease or loss, and plus sign means gain of energy. So here for adiabatic process, decrease in internal energy. For adiabatic process, decrease in internal energy is equal to the work done by the system on its surrounding. So for an adiabatic process, decrease in internal energy is equal to work done by the system on its surrounding. So this is a special form of thermodynamics, the first law of thermodynamics for adiabatic process, where it states that decrease in internal energy for adiabatic process is equal to work done by the system on the surrounding. That is for adiabatic process. Now for isobaric process. Now we know that isobar, just like we have seen the definition of isochoric process. Iso means same, core means volume. Process in which volume of the system remains constant, there is isochoric process. What is isobaric process here? This iso means same, bar means pressure. So isobaric process is a process in which pressure of the system remains constant. That is actually delta P is 0. Delta P is 0. That is pressure of the system is remaining constant. So isobaric process is a process in which pressure is remaining constant. But here, according to the first law of thermodynamics, that is Q is equal to delta E plus W. Q is equal to delta E plus W, and W is equal to P delta V. We know the one form. And here, therefore, we can write here simply Q is equal to delta E plus W, or delta E is equal to Q minus P delta V. So this is simple form where we have just brought this term from one side to the another side of that mathematical equation. So here the first law of thermodynamics is over. I hope this concept is clear to you. So what we have seen in this lecture, that is, we have seen the different forms of the first law of thermodynamics, which is related with the interconversion of one form of energy into another form, and we have also seen the different statements for the first law of thermodynamics. And always remember here the mathematical form of the first law of thermodynamics, so that it can be applied for different processes, that is isobaric process, isochoric process, adiabatic process, and cyclic process. So here the mathematical form of first law of thermodynamics is what? That is Q is equal to delta E plus W. Q is equal to delta E plus W. So that is the mathematical statement of the first law of thermodynamics.